Hi guys, this video is going to go over some stuff you did last week and this week, and then you have a second video today that you're going to watch, and I'm going to show you a problem. You're going to pause it, you're going to try it, you're going to turn it back on, and see if you did the problem correctly. Okay, these are the types of things that I do in a regular classroom, and I think are really important that we do together like this. Okay, so that you can try a problem and then immediately see me do the problem, see the work, see my strategies, and kind of compare your work and my work. Okay, so that's what we're doing. So let's first, just so you know, we are going over 3.4 and 3.5. Okay, so if you're kind of looking in the book where I'm at, that's where we're at. So, first of all, I want to discuss with you, and you can label your paper like this, multiplying rational numbers, and then we're going to do dividing rational numbers. Okay? So, one of the focuses of, first of all, when they're telling you rational, so remember our NWIR. So if I look at NWIR, here I have counting numbers, 1, 2, 3. Whole, I add in 0. Integers, I add in negatives. And rationals, I'm really adding in fractions, decimals, and I have negatives, and I have 0, and I have all these other numbers. So when you see something with integers, you should be thinking, I bet we're going to talk about negative numbers, because you've done natural and whole kind of in your previous years where you just really learned how to add and subtract and multiply and divide just regular numbers. This year, we moved up to integers and started talking about negatives, and we've talked about our signs. Now we're moving up to rationals, which should tell you that we're talking about fractions and decimals. Yes, under rational are all these other numbers that we've talked about, but if I say rational specifically, it should tell you, oh, we're probably talking about fractions and decimals, because those are the type of numbers that are in the rational category that are not in the rest of these categories. Okay? So, what I want to start with is an example. So negative 3 over 4 times negative 4 over 7 times negative 2 over 3. Okay? Now, just technically, you can multiply these straight across. Notice, I put all my negatives up with my top number. You can do it other ways, but that's a strategy to help you. So, when you are looking at this, you could do 3 times 4 times 2, 4 times 7 times 3. Okay, but then you're going to have the really big numbers that you need to reduce. So instead, let's use our cross canceling. And what's nice about cross-canceling in this problem is I can cancel anything in the top and the bottom, whether it came from the third and the first fraction, the first and the second and the first, anything from the top to the bottom. So I'm going to first cancel my 4s. Don't lose that negative. And then I'm going to cancel my 3s. And so now the only number I have left in the top is 2, and the only number I have left in the bottom is 7. Now we need to talk about signs, okay? So I want you to first think, a negative times a negative turns positive, okay? And then that positive times another negative turns back to negative, okay? So just remember, a positive times a negative is negative. A negative times a positive is also negative. And then if you have the same signs, they both give you positive. So here you had the same signs, so we got a positive, and then because we had a positive with the negative, that was different signs, and we ended up with the negative, which makes our answer negative. I'm going to tell you a rule, though. Okay, so pause and copy this if you need to, because I'm about to erase it. So here's a rule. All right, and it's kind of cool. If I have a negative times a negative, I get a positive. Times another negative, I go back to negative. Times another negative, I go back to positive. Times another negative, I go back to negative. Okay, so hopefully you're seeing that pattern. Now, something you could remember as a general rule is odd amounts of negatives. Okay, this is all for multiplication and division. They're always the same rules. Don't forget that. Odd amounts of negatives give you a negative. Even amounts of negatives give you a positive. Okay, so maybe you write that down. Well, not maybe. Definitely write that down and kind of remember that. So if you look, our original example had 3 numbers that were all negative, and because it's odd, your answer turned negative. Okay, so pause and write that down. That's really important that you see that pattern. So let's try, let's look at one more. So if I have negative 2/3 times negative 3/4 times 4/5. I want you to pause and I want you to try to do what I just did. If you're feeling a little stuck, you could just keep going. Okay, so the first thing we're doing is we are looking to cross cancel. So our 4s are over each other, our 3s are over each other. That leaves a 2 in the top and a 5 in the bottom. And there's only 2 negatives, which makes it a positive 2/5. Okay, hopefully that makes sense. I'm going to move on to complex division. I know, that word probably didn't make it sound very fun. Don't be worried. Don't be worried. Okay, so keep on the same page, but just put a new title. So like if you're halfway down a page, just make this a little bit bigger. And we're going to write complex fractions. So what these look like, and actually I've kind of introduced these to some of my students before, so this may feel, oh, sorry, I got to plug in my computer here. I'm going to lose you. Too far to lose you. Okay, there we go. All right, so complex fractions. This is what they look like. And you're going to go, as soon as you see what it is, you're going to be like, oh, we didn't need the word complex. It's not that hard. So 7/10, regular fraction, over negative 1/5. So when I first look at that, oh yeah, complex. It looks crazy. But you have to realize this just means division. So I can make this 7/10 divided by negative 1/5. And as soon as I have it like this, it's what I've been practicing. And I see that it's nothing different. It just looks crazy. So don't fall for their tricks and feel, pressured and not get this problem done. You just need to rewrite it in a format that works for you. Okay? So from here, just as a reminder, we make it a multiplication problem. We flip our second fraction. We can cross cancel. Oops, that should be a 1. And that should be a 2. So 7/2, and there's only 1 negative. So because there's only 1, and that's an odd number, I know my answer is negative. Okay, so this really complex fraction really just meant division. All right, pause that if you need to because I'm about to erase. So here is another version of that. 3/4 divided by 1/12. So I'm going to immediately rewrite it in a format that I like. And try not to mess up my numbers. Then I turn it into a multiplication problem. Then I cross cancel. And then I finish the problem. And because everything's positive, I know my answer is positive. Okay? Hopefully that makes sense. Now, this is the one that I really want to remind you because I think that even though you've learned this before, we forget how to do this. And the next type of problem really opens us up to a lot of mistakes. Okay, so pause if you need to write this down, so I'm about to erase. .72 over negative 0.9. Now you don't really need the zeros. I'll put it there in case it confuses you. Okay, but often you're going to see me put just 0.9 or 0.72. It really means the same thing. I would get used to that, okay? So what we're going to do is we're not going to pull out our calculator. I know you really want to, but don't do it. We're going to put the 0.72 underneath, and we're going to put this 0.9 on the outside. Now, we cannot forget to come back to figuring out what our sign is. So we have a positive divided by a negative, different signs. Another way of thinking of it is only one negative, which is odd. So we know our answer is negative. And maybe you write that. You know, you get yourself ready to fill in your answer, and that way you don't forget your negative. Because usually when I talk to students and I say, hey, you forgot a negative, like, oh, I knew, I just forgot. So if you write it and you kind of make that decision first, that might be a strategy to help you not forget. Okay, so let's look at this. Now, when I'm doing this, I don't want to put a 0.9 into anything. I want to work with a 9, so I'm going to move this decimal this way. Now, if I move that decimal, I move this decimal the same number of times. Okay, so instead of putting a 0.9 into 0.72, you're putting a 9 into 0.72. Okay, so when I am looking at this, I realize I can't put my 9 into 7. So I move on. Now, because my decimal's here, I need a decimal up here. And if you want, you can leave yourself a 0, kind of like we talked about over here. Now I'm really putting a 9 into 72. Okay, so don't think about the decimal. You've accounted for the decimal right here. You don't need to think about it anymore. So 9 into 72, I'm going to use my 9 tricks, and it is 8. 9 times 8 is 72. I have a remainder of 0, so I am done. So 0.8, and then I want to make sure it ends up in my answer box so that I don't forget that negative, because it's so easy to do. Okay, so just a little recap. You are going to put the number in the top of the fraction underneath. You're going to move that decimal however many spaces so that you get a whole number out here. And however many spaces you moved it here, you move it here. And wherever you move it, you make sure it ends up there in your answer. And then you do regular long division. And honestly, if you forget regular long division, go on to Khan Academy, look up long division, watch a short video, you're going to remember it. And if you need me to find you that video, just email me and I will find you a video. Okay, so for the rest of your, for your second video, we're going to try some more of these problems together. Okay, so I'll see you in a second.